Section 7.5, factoring x squared plus bx plus c. The leading coefficient is 1. So our objective for this lesson is going to be able to factor a trinomial. We are going to be factoring a trinomial. Again, a trinomial is a polynomial with 3 terms. It's going to have 1, 2, 3 terms. The first term is going to be degree 2. We'll have a good degree 2 as the first term. The second term is degree 1. Oh, that's not how you spell degree. Okay, degree 1. And then the third term, the very third term is a constant. We're only going to be factoring polynomials of that pattern. First term is degree 2, second term is degree 1, third term is a constant. And because these are the easiest trinomials to factor, and then we'll kind of work in complexity. Our reason for wanting to be able to factor is actually from that section 7.4, using that zero product property. If it's factored equal to 0 and set equal to 0, we're able to solve it by setting those factors equal to 0. So if it's not factored, we need to factor it. Today we're going to be dealing with the leading coefficient. The first term, its leading coefficient is 1. So we'll have 1x squared plus something x plus something. Okay, we'll put a b there and a c there. But an important thing to remember, this step only, our process we're doing today only works when that leading coefficient is 1. If that leading coefficient is something other than 1, then we're going to have to learn some other methods. Okay. Also, we're only able to factor if it's in standard form. Okay. So we need it in standard form, meaning we want it in decreasing degree. Hence, start with degree 2, then degree 1, and then a constant. It needs to be in that order. If it's not, you have to rearrange it. Okay, so you might need to rearrange. Okay. All right, the book, this textbook actually teaches 3 separate rules depending on where the negative sign is. I do not teach it that way. I have one rule. We apply the negative onto the number itself, and we do that same rule for all of them. So if you use the textbook, my notes don't match the book. There are many, many different ways to factor. I'm trying to teach you what I feel is the easiest way. Okay, so first we're going to start here. We're going to factor x squared plus 10x plus 16x. So since this is a trinomial, I know it's going to factor into a binomial times a binomial. Okay. Okay. So I know the first term needs to get me this first x squared. Well, to get to x squared, I'm multiplying x by x. Okay, so all of these are going to start with that x by x. Okay, but now I need to figure what goes here. Okay, so what goes here, this last spot here needs to multiply to give me 16. So it needs to multiply to give me 16, but it also needs to add to give me that 10, because when I distribute, we'll have those what we call middle terms. It needs to add to 10. So I'm looking for 2 numbers that multiply to give me 16 and that add to 10. So if you can't find them, we can always list the numbers that multiply to give me 16. 1 and 16, 2 times 8, 3 and 3 and 4 and 4. They would all have to be positive because this is a positive 16. Okay. And then which one of these are going to add to 10? Well, the 2 and the 8 will. Positive 2, positive 8 will add to 10. So we'll have positive 2, positive 8. And then we always check our work, because you can check these quite easily by multiplying. So I'm going to come over here. I'm going to write check it. So I'm going to multiply x plus 2 times x plus 8 and make sure it works out. Distribute. X times x is x to the second. X times 8 is 8x, 2 times x is 2x, and 2 times 8 is 16. So we get x squared plus 8x plus 2x is 10x plus 16. Yep, that got me back to the original, so it worked. So we found how it factors. There it is right there. Okay. All right, we're going to always be doing the same process. We want to multiply to get our constant, and we want to add to get our middle term. So multiply to get the constant, add to get the middle term. The only thing that maybe might make it a little more complex is the negative. But I'm just going to, first thing I'm going to do when I see a negative is I'm going to write add a negative, and I'm going to put the negative on the number. Okay. Again, still, this is going to be a binomial times a binomial. 2 terms times the 2 terms, and the first one is x by x, because x times x gets me that x to the second. Again, I do the same process. I want to multiply to get 12, but I want to add to get negative 8. So if we go ahead and look at the multiples of 12, we have 1 and 12, 2 and 6, 3 and 4, but I want to add to get negative 8. Okay, well, right now they're all positives. But if I make them both all negatives, when I multiply negative 1 times negative 12, I get positive 12. Negative 2 times negative 6 is positive 12 because a negative times a negative is positive. But then if you notice, when I take this negative 2 plus this negative 6, I get negative 8. So the numbers I'm looking for are negative 2 and negative 6. So it's going to be minus 2 and minus 6. And you will start eventually noticing a pattern with those negatives. Here, since this is a positive, I know both of these are going to have to be a negative because they need to multiply to give me a positive. Okay. And again, we want to check our work. So we come over here and we're going to check it. So I'm going to multiply it out. X minus 2 times x minus 6. We get x squared minus 6x minus 2x plus 12. So x squared minus 6x minus 2x is minus 8x plus 12. Yep, it worked. So there I am in factored form. Basically, just figured out what multiplies to get me back to that polynomial. Or basically, we're unmultiplying. Oh, why is that glitching? So there, x minus 2, x minus 6 are the two factors. So multiply in between. All right. Next one. Again, here we have a negative, so I'm going to write this as plus and negative. So I have negative 21. So I'm going to have to multiply x by x to get to the x to the second. Now, again, what multiplies to give me negative 21 adds to give me 4. So I want to get to negative 21. So, well, 1 and 21, 2 doesn't go in there, 3 and 7. Well, 1 and 21 is 22, 3 and 7 is 10. I want to add to get to positive 4. Important thing to note here, but I want to multiply to get to negative 21. When I multiply these, I get positive 21, which tells me that one of them is going to have to be negative. So if we have negative 3 times 7, that gives me negative 21. But but negative 3 plus 7 is positive 4, because they're different signs. So that tells me I'm going to need a negative 3, and a positive 7 to get negative 21 when I multiply them. And when I add them, I get positive 4. Again, check your work. If you check it and it doesn't work out, then you know you picked the wrong numbers and you need to try something else. So we're going to check it. X minus 3 times x plus 7. X times x is x to the second. X times 7, positive 7x. Negative 3 times x, negative 3x. Negative 3 times 7, negative 21. X squared. When I add those, I get positive 4x minus 21. It worked. So we found how it factors. Okay. All right, our last example. A farmer plants a rectangular pumpkin patch in the northeast corner of a square plot of land. Okay, so here we have the square plot of land, and they tell me it's S by S. S meters by S meters. The area of the pumpkin patch is 600 square meters. They don't have that in this drawing, so I'm going to put it in. The area in here is 600 meters squared meters. Okay. What is the area of the square plot of land? So we want to know the area of this whole thing. Okay. Well, I'm going to use the fact that I know the area of this piece to set up an equation. I know this piece is a rectangle. Now to come up with what is this length here? Well, if I know the whole thing is S and I'm backing it off by 30, I know this is going to be S minus 30. And this piece, this whole thing is also S, but I'm backing it off by 40, so this is going to be S minus 40. And to find the area of a rectangle, I take length times width. So I know S minus 40 times S minus 30 has to equal 600. Okay. Now, if this equaled 0, this would be an easy process. I just said each factor equal to 0, but it doesn't equal 0. Right now, it equals 600. So I'm going to need to distribute this guy out and subtract the 600 over. So I'm going to distribute S times S, that's S to the second, minus 30S, minus 40S, plus 40 times 30 is 1200 equals 600. So put together like terms, S squared minus 70S plus 1200 equals 600. So now I need to subtract the 600 from both sides because we want to set it equal to 0. So over here we get 0. So I'm up with S squared minus 70S plus 600 equals 0. So now that I have it equal to 0, I can solve it by I need to factor it. So I need to figure out what multiplies to give me this guy right here. So this is very similar to our other previous problems, except the numbers are a little bigger. I'm going to have S times S. The leading coefficient is 1. I've only got 1S squared, so we can use our pattern. And now I want to multiply to get 600. So over here, I'm going to multiply to get 600, and I want to add to get negative 70. So I want to add them to get a negative 70 over here. Okay. So I'm going to go ahead and I'm going to divide 600 by some stuff. So we've got 1 and 600. I want to add to get negative 70, so that tells me that they're both going to have to be negative for me to get negative 600. For me to get positive 600, they both have to be negative. So what about negative 2, negative 300? Nope, that's negative 302. Negative 3, negative 200. Nope, negative 4 times what? So I'm going to have to divide 600 divided by 4. Negative 150. Nope, negative 5. 120. Oh, negative 120. 6 and 100. Nope, 7, 8. 8 and 75. Nope. 9, I don't think goes into it. We could try it. 9. Does it go evenly? Nope. 10? 10 and 60. Ooh, I think I found it. Negative 10 and negative 60 gets me positive 600. When I add them, it gets me negative 70. That one took a little while, but then we had a calculator. So negative 10, negative 60 equals that 0. So now that I have a product equal to 0, now I can set each one of these equal to 0. So S minus 10 equals 0, or S minus 60 equals 0. Flashback to section 7.4. Add 10 to both sides on this guy. So S equals 10, or add 60 to both sides of this. S equals 60. Okay. So let's go back and look at our original problem. So we have two different answers. Either it could be 10. So either the side could be 10. Well, if it's 10, it doesn't really make any sense because, okay, if the whole thing's 10, this little bit's only 30. So the whole thing, the whole length of this can't be 10 if this little bit be 30. So 10 doesn't make any sense in terms of this problem. So the 10 doesn't work. Okay. So then it's going to have to be 60. This 10 is what we call, in this case, an extraneous solution, or a one that doesn't work in context. Doesn't work in context. Meaning in terms of this problem and it being the length of something, it just doesn't work. So it's always good to check your answers. So they'll both be 60. They want to know the area of that square plot of land. So the area is going to equal 60 by 60, which is 3,600, and that would be square meters. So there's our answer. The area of that square plot of land is 3,600 square meters. Okay, so here's your practice. Page 389, 4 through 38 even. Good luck.